Welcome to the Voluson Performance Series video tutorials. 3D surface rendering. When acquiring a 3D volume, there are certain settings you must optimize. Before you begin, ensure that you are using the correct imaging preset and that the anatomy that will be the center of the volume is the 2D imaging plane that you begin with. In this example of a fetal profile, begin in the profile plane. It is important to note that there needs to be a layer of fluid over the area of interest in order to obtain a good quality surface rendering. To begin the acquisition, select the 3D 4D control. A region of interest box, or ROI, will appear on the monitor. 3D is a single acquisition that results in a static 3D volume. 4D is several 3D volumes performed over time to enable you to see movement. 3D 4D has its own set of presets, so when preparing to acquire a volume, first select an appropriate 3D preset. Use the trackball to place the ROI over the area of interest that you may want to acquire as a volume. Position and size this box using the trackball and set keys. The area within this region of interest is the information that will be included within your volume. The green line is the render line. Everything below the green line will be displayed in the rendered image. Use the trackball to move the ROI and place the green line within the fluid. The green line can also be curved to help avoid any areas you don't want to include in front of your rendered volume. When acquiring a volume, you must also determine that the width of the volume will encompass the anatomy you need to include in your volume. This control is called volume angle. For instance, in this example, you will need to determine that the volume angle is wide enough so that the transducer will move and acquire from outside one cheek, across the profile, then across through the other cheek. The resolution of the volume is controlled by the quality setting. As in 2D, most image quality enhancing settings are a trade-off with frame rate. This is also true in 3D 4D. The higher the quality setting, the slower the acquisition time, thus collecting more information in your volume and increasing resolution. If the fetus is moving a lot, you may want to lower your quality setting, sacrificing resolution for an improved volume rate. Once these parameters are set, you are ready to acquire the volume, either static 3D or in a real-time 4D to help ensure clinical confidence. From the profile view, select the Start Trackball key. Once the acquisition is complete, the volume will be displayed depending on how the preset is set up. It could display in a dual display with both the rendered image and the acquisition plane, as just the rendered image, or in a quad display showing all of the orthogonal planes along with the rendered image. Selecting the Freeze key or Vol-Pre trackball key will cause the system to return to a live scanning state, so it's important to store the volume as soon as the acquisition is complete. In this quad display, the upper left image is called the A plane. This is the acquisition plane. The upper right image is the B plane, which is 90 degrees orthogonal to the A plane. So if the A plane was sagittal, the B plane would be transverse. The lower left image is the C plane, which is also orthogonal to the A plane. If the A plane is sagittal, the C plane would be coronal. The lower right image is the rendered image. This is a compilation of all image data within the region of interest. In this view, the rendered image is oriented in the reference to the square and diamond. The diamond references the diamond seen in the A plane. In this image, the diamond is oriented at the fetal chin in the A plane. The same orientation is seen in the rendered image. The square references the beginning of the acquisition. The square in the B plane is on the same side as the rendered image. The fetus in this example is shown upside down because the fetus is vertex, evident in the A plane. The rendered image can be flipped 180 degrees and the square and diamond move accordingly. After the acquisition, the volume displays in an edit mode. While in the edit mode, the region of interest is still active and the upper trackball key will change between sizing the ROI box or moving the image to the box. Note that the graphic ROI is stationary. The image moves to the ROI. These movements are all performed in relation to the reference image, meaning if you size the ROI in the A plane, you'll notice you lose top-bottom information in the rendered image. But if you activate the B plane, that same sizing action now reduces the volume side to side. Notice that zooming the image has no effect on the ROI box when you're in edit mode, unless 3D is selected as the reference image. If you no longer want the contents of the ROI box to be adjusted, select Edit ROI to turn off this feature. Some of the main controls in 3D are rotational axes. The mode control knobs are converted to rotational axis controls when in 3D 4D. The X-axis rotates the volume on a horizontal axis. The Y-axis, accessed by pushing the PW control knob, rotates the volume on a vertical axis. The Z-axis rotates the volume in plane like a cartwheel. The parallel shift key shifts through the various planes in a parallel fashion. Threshold. Sometimes the rendered image may appear dark as you are rendering through the fluid. Threshold will eliminate those low-level echoes from the fluid. Gain. By using the raw data technology of the Voluson Performance Series, you can adjust the overall brightness of the volume. Gray levels. The left number affects the whites, so you can increase or decrease the intensity of the whites. The right number affects the blacks. You can increase or decrease the intensity of the blacks by pushing the control knob, then adjusting. Set rendering. This allows you to choose from varied 3D presets depending on what anatomy you want to evaluate. All rendering uses a combination of two different render modes. You can adjust the mixture of them to best visualize the anatomy of interest. Magic Cut allows you to eliminate portions of the volume. The simplest way to do this is to first choose Magic Cut, then rotate the volume on the X or Y axis to free the obstructing area from the area you want to retain. Once the obstruction is free, move the trackball to the image area, select Set to begin, draw around the area, then select Set to erase the unwanted information. An important point to remember in Magic Cut is that the original acquisition was still subject to normal sonographic imaging challenges. For instance, if there was an arm above the face in the volume, there would have been a shadow cast from this arm. Cutting away the arm does not eliminate the shadow under the arm. The Voluson Performance Series is an easy-to-use system with excellent image quality and performance to help meet the needs of your clinical practice.